Hi everyone, my name is Nils Mohr. Jake is over there, he's doing a second part of the talk. So very welcome. Obviously if you like airplanes like me, you're in the right room. If not, sorry, there's plenty of aircraft pictures in our presentation. Yeah, tough luck. So while we're looking at some stunning pictures that I snagged off our PR people, 100 years of British Airways, 100 years of flight data of British Airways is actually a bold-faced lie. From our point of view, we've been around for quite some time, but as a team and as what we're doing, not quite 100 years, but let's gloss over that for the moment. First things, what are we going to talk about today? A bit of our heritage. We're old, we're British. I'm not, so sorry about that. But in essence, yeah, where do we come from? Then probably something that you're not too familiar about is what we consider flight data is potentially maybe a bit different to what other people consider as flight data, so touch over that. I will be talking about our journey on Amazon, what we did over the last 2.5 years, and then Jake will come in with a bit of a bigger picture of what BA as a group or as an airline is doing altogether. So, I like that picture. Our heritage, where do we come from? This is really old stuff, black and white pictures on the left side. This is our first flight. Then you got the 1920s, 1930s. And in essence, there was not a lot of flight data around. You had a lot of paper that got carried from A to B, and people were starting to look at stuff. But for me, from an engineering point of view, and this is where I work, yeah, it was not to our modern standards. Then the picture on the lower right side is a Comet, which, well, was the first jetliner. It was British built. Unfortunately, it had square windows. And because it was flying so high, the square windows introduced fatigue cracks, which led to a series of unfortunate losses of that aircraft type, which left investigators quite clueless. So in essence, that aircraft was the first, or the reason why we have the black box as it is on modern day aircraft, and this is sort of where our program and our sort of team initially started. And in essence, the first glory moment is in the late 50s, early 60s, BEA, the sort of European subsidiary, introduced the Trident, and one of the key features of that aircraft was being able to land at Heathrow or other places in the fog. So that means that aircraft was the first aircraft to land automatically without a pilot touching, and in order to get that past the authorities, there were two options. You could do some other bits that were not really accepted, like analog recordings, and then have people actually looking at stuff. But clearly the authorities said, no, we're not having that. So in essence, what they wanted, digital recordings analyzed by digital systems. So from our point, you had the first ever digital computer to record a certain set of parameters on that aircraft. And then on the ground side, you had people that taking that recording off, processing it, and analyzing that, and eventually that thing got certified and flying in the air. So at that point, obviously Concorde is one of our jewels. Those kind of aircraft in the 60s and the 70s, we had stuff that run on tape, that recorded things on tape, and obviously, yeah, it's not really ideal. In essence, over time, with later generations like those 747s, you went to tape recorders with actual microprocessors, so you had stuff that you can buffer, because in the air, as you probably all aware, it's not always a smooth ride, smooth sailing, so in essence, you can buffer things, you can write to tape, you can check stuff. However, a slight snag, the tape was only good for about 8 hours of flight. We fly 12 hours, so you got some really weird compression stuff happening. In the end, we switched then over to optical tapes or optical discs, which had a nice benefit of having much more memory, and we're talking about 128 megs, which is like nothing that wows anyone these days, but at the time it was brilliant. However, it got quite dirty. So those tapes, those optical discs, had the advantage of having more capacity, but also the disadvantage of being clogged up all the time. At this stage, solid-state memory got cheap, so everyone moved to solid-state cards, and now we're in the process of going wireless with our new shiny new toys. And that's pretty much where we are with our history. There's plenty of more stuff that I'd like to talk about, and probably some of you will get quite glazy at that point. But yeah, we went a bit over the top. If you're curious, I'm more than happy to bore you all day long. So questions and stuff, just come over. So from our point, let's get juicy, let's get to the juicy bits, our engineering data set. In essence, we have 3 sources of data that we regularly work with. One of the source of data is something that is a bit new to us, and thanks to what we can do on AWS, we plan to expand on that, and that is what we consider tech-log data. So every aircraft comes with a stack of paper that is literally a couple of tons, with all the records, all the details, and whatever you have in terms of start of service in BA to current date. That stuff gets not thrown away, that sits around somewhere and gathers dust. This is what we do right now on our new fleets. Obviously, pilots do like their toys, so we gave them iPads. And in essence, they use that technology to just write logs down and sort of what happened on that flight. And we on the other side then start to see when we hand that aircraft back to our engineers, okay, this has happened, what do we need to do now? And in essence, that is basically a really juicy data set that we get more into. At the moment, from what we are using is the 2 data sources that I'll be talking about now. This is ACARS. It looks absolutely brilliant. It's ASCII-based text stuff that it gets transmitted via SATCOM, or so satellite or radio communications. It's pretty much real-time. It was designed in the 70s, 80s, so you have about a 4 kilobyte message limit, which is amazing. But in essence, this is what all the real-time communication works with these days. There are some newer technologies like Swift Broadband, which cost you an arm and a leg, so not really many people are using that. However, the really interesting data set from our point is what we consider flight data. And this is what we can see here. So you got altitude, heading, speed, and engine speeds, engine power on there. And that's a time series data set that gets sampled between every 60 seconds to up to 5 to 10 to 20 times a second, depending on that parameter, depending whether it's of interest or not. And in essence, again, depending on the age of the aircraft, we have between 1,500 to maybe 10 or 15,000 parameters that we capture and we aggregate on a regular basis. And that obviously grew from sort of mid-70s, where we started using that data set for predominantly sort of flight ops and certification purposes, to now where we actually start making use of that data for engineering purposes. And in essence, let's talk AWS now, so done with the boring bit, hopefully. What are we doing? So our goal is give everyone that travels on BA a bit of a smoother ride. Hopefully not too many people in this room or anywhere have been on an aircraft and sort of stuck somewhere at Heathrow or another airport and it's like, yeah, this is your captain speaking. Unfortunately, there's something maintenance, whatever, blah, 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 and you just go, oh gosh. In essence, we are trying to use that data and see when and if we can spot deteriorations in our mechanical systems, and sort of, rather than having you stuck at the airport, predict those failures and then plan that maintenance, and so you get a smooth ride to your holiday destination or your favorite conference or whatever. So with that in mind, in roughly 2016, we started with our architecture, a bit of on-prem stuff. We used a lot of Python, Flask. We had a Postgres database, and well, an Angular front end because that's what the cool kids used at the time. Yeah, so case made, it's like, yeah, okay, whatever, go away, do stuff. We had a few options. Thankfully, we have a sort of a bit like a startup incubator thing in BA that say, oh yeah, you should look at Amazon. It's, yeah, again, what the cool kids do. So, well, go for it. So, step one for us, well, every good story starts in S3. We have our aircraft on the side. We need to move all our stuff that we capture from the aircraft into Amazon. And in essence, we have satellite, we have cellular technology, we have Wi-Fi, we have actual physical media cards. So that's a bit of a challenge. On-prem, we have a sort of database and managing application that we call FDB for Flight Data Database. Very creative naming here, I'm sorry. So we just created a second pipe that moves stuff into S3. Job done. So that gave us with probably one of the largest sets of flight data that are available in S3, which gives us a lot of data to work with, which is nice. So initially we started looking at, okay, how do we build stuff? Well, we had a lot of Python, we had a lot of API bits, so Lambda seemed like a really good idea. And that's exactly what we did. We looked at Lambda, we put our API into API gateway into Lambda. We had a bit of back-end processing that we also put into Lambda. And eventually this looked a bit like this. So we have our S3 storage. We have, at that time it was RDS as Postgres. And we had a bit of Dynamo in there as well. At that time also Lambdas were limited to 1.5 gigs of memory. So we had to do some steps in EC2s actually. But we trigger SQS messages, we throw it over from a data optimization point to metadata generation. This is something that we do with, or what we call as flight splits. We have a bit of data and you just say, okay, this bit here is a flight from London to JFK, and then you have a flight from JFK back to London. And you also get like flight numbers, timestamping and all that sort of stuff. And the second, or the last step is then actually what we wanted to do is, well, now that we have that data, how do we evaluate that? We have a set of problems that we want to deal with. Well, let's stick that stuff in a Lambda as well, plus all the other bits that we use for API gateway backend calls. So in BA, if you do stuff on Amazon, we have a bit of a weird requirement, and in essence that is you have a production and a non-production account, and those are actually separate accounts. So in essence, well, you need to do stuff, infrastructure as code. So we had Lambdas and they kept creeping up on us. After sort of migrating everything into Amazon, we had about 80 Lambdas. So we looked at infrastructure as code, and in our ignorance, we just turned to the first solution, which was CloudFormation. So all this stuff into CloudFormation, yeah. We're a sensible organization, so I'm not allowed to put any pictures that describes the state of everything into one CloudFormation. So I'm sorry about that. But just picture something really, really not nice in there. But in essence, just don't do it. You know, the thing about microservices is you got a lot of stuff going on. You don't want to have CloudFormation scripts with like gazillions of lines of code. Just do it on a function basis, do it on a microservice per script basis. You will thank me later, or you just use Terraform. So in essence, there's a lot of stuff that happens, and especially if you're working with Lambdas right now, it's still, I mean, that's probably a thing that I can skip out or take out of that slide soon. If you create Lambdas with CloudFormation, and then for some weird reason your CloudFormation rolls back because you cocked something up, you have to wait 45 minutes because of the network interfaces that need to be torn down. So I think you guys have released something on that topic that changes how Lambdas interact with network interfaces and VPCs. So hopefully that's a thing of the past soon. But in essence, when we started this journey, that just cost us basically a day because you could do 5 deployments, and if you tore it back down, you have to wait for 45 minutes. So you got everything as CloudFormation, which is nice. Next step is now CI/CD. Ooh, everyone likes that, so do I, because I want to do less work. So you left disappointed at that time. There's no real toolkit for doing CI/CD with Lambdas. I'm looking at you guys, so make a move. You know, you can deploy zip files into S3, and you just wonder, well, why do you stop there? Why not go into Lambda directly? So, well, bollocks. In essence, from our point, what we did is we're running everything in Python. We were quite familiar with that. We're using Bota 3. Well, you can write yourself a Lambda function or another function or just a script that zips stuff up, puts it into S3, and updates your Lambda code. So we did that. Yay, amazing. Slide snag, clean up your crap. So you have about 75 gigs of code storage in a region, and if you deploy Lambda functions into your infrastructure automatically that way, you're creating a lot of wreckage if you're not cleaning up the old versions, and especially if you're updating everything all the time. So, subtle hint, the dirty work needs to be done. In essence, what we then started to do at some point after Amazon allowed us to have 3 gigs of memory, we can say, yay, we can get rid of that EC2 because nobody likes to manage EC2s. If you do, I'm sorry for you. So in essence, all Lambda process, are we happy now? Well, let's talk about libraries in Lambda. So initially, yeah, sort of some bits and pieces. You need a connector for Postgres, which is easy. It's a couple of megs, nothing to worry about. Well, we use NumPy as a library, okay. So in essence, we got quite comfortable, and at some point too comfortable, because we got that a lot. You can only do at 260-ish megabytes in Lambda. If you start stacking your files up, you just go, oh, So eventually, this is what our Lambda functions look like. Yeah, obvious solution, Docker to the rescue. At that time, we were looking at various options. Essentially, I'll just take that away. We opted for Fargate. You got other options, just saying ECS, EKS if you want to, Kubernetes if you've had masochistic, up to you. So it's the usual suspects, basically. From our point of view, we're a really small team, so we're managing everything ourselves. With Fargate, there's not a lot to manage. So other bits is obviously, it seamlessly integrates with code pipeline, code deploy, so you just have a Git and it just rolls through. You also have sort of scaling between 0 and 50 tasks, which is where we're sort of flying around usually. And the last thing is no maintenance, no headaches, and obviously no downtime, unless we cock it up. Downsides, yeah, you have to deal with CloudWatch. We can't use Prometheus that easily with Fargate, so sorry for that. And obviously, it's a managed service, so it is more expensive than running Kubernetes yourself, but you don't have to run Kubernetes yourself, which is an upside for me. So basically, we swapped everything out with containers. We're running Fargate stuff now. So that looks good. Are we happy now? No. If we look at our last step, so we have this metadata generation where we do timestamping and flight splitting and all that cool stuff, which is basically a simple example here now. So for fleets for us, we have 6 in total, but as an example, 4 files from aircraft coming in. Yeah, so if we now expect our thing to be successful, we will have multiple bits of components that we want to monitor on those aircraft. So in essence, well, that SQSQ started to pile up and took forever and always to actually, finish all that processing. Amazon is quite good at scaling, so we thought, well, we should be able to fix that. So as a solution, yeah, very simple. You can do Fargate auto-scaling based on SQS. Our containers have very, very heavy bones, so it's not really a lightweight thing, unfortunately, at this point. So yeah, you can do that. That's a bit of a slow process. On the other side, you can look at lambdas again and say, well, lambdas can be triggered by SQS now. Does that offer me any solutions? It does, actually. And that's thanks to something that got introduced last year at reInvent, layers. We're quite heavily using layers. So in essence, we swapped the last containers with, or replaced the last container with a Lambda function that is powered by layers. And in essence, what layers does for you, previously we had this big gob of code and libraries and all the other crap that we never bothered to clean up. And in essence, we just converted that into 3 bits of zip files. You know, you have this little tiny business logic that we run, and then you can just separate things out in different layers, which gives you a really neat way of getting rid of that big headache of having to wonder whether your deploy actually works or you just broke a library or something else broke. And on top of that, the Boto3 library on the Lambda AMI is old, like really old. So for example, we use SageMaker a bit. It's not in there, or at least not the stuff that we need. So one good thing is if you're doing stuff, just package your Boto3 in a layer, stick it on there so you know what you can expect. There's some other advantages, but in essence, there are some key benefits for us by separating things out, and the biggest one is our Lambda used to be 60 point something max, which is about a few bytes away from being rejected by Amazon, and now we're down to 500K, so it really speeds up that entire process. However, CloudFormation and Lambda layers is not really a match made in heaven, unfortunately. So what we started doing is we had a master stack that built all the layers, and then a few nested stacks, because I was like, yeah, well, we have one template, one script per function, per microservice. So you just have one layer, and then you put that, create outputs. Stupid idea. You can't update outputs in CloudFormation scripts if they're used elsewhere. So you just go like, well, And if you then fiddle other ways around, and you clean up your mess, because you're obviously very keen and programmer with a bit of OCD, CloudFormation will eventually complain that the version that it's currently referencing to no longer exists, and you're stuffed. So in essence, what we did here is this exact thing. Yeah, didn't work. Cut a long story short. What does work, and that's a bit of a fudge, move everything into parameter store, reference layers there, and then let the nested stacks pull it out of parameter store. And from my point, that's a solution that is obviously working at the moment. You can also use Terraform or other bits and pieces like that. But in essence, you have a lot of things that you want to consider, especially if you create big stacks in CloudFormation. I think there's a lot of work happening on CloudFormation as a service at the moment. There's a public roadmap on GitHub, so please file bug reports. Because, yeah, it's a bit of a touchy subject. But from our point, this is where we are. At the moment, we're looking at a few other things. So we started off with this big Postgres database. We're now trying to split things off into various directions, sort of a bit like CloudFormation, one database per service, or where it makes sense. So rather than having a big beefy instance that runs your Aurora or whatever you're using, we're just trying to look at Dynamo and Aurora in combination and sort of leverage the benefits depending on what we're trying to do. And on the other side, we have a bit of experience with SageMaker. So in essence, what we're trying to get into is, rather than us scripting a lot of our infrastructure, or well, our problems that we want to monitor for, or we're just looking for anomalies and all that sort of weird stuff that never happens. You know, that's pretty easy with unsupervised learning, and obviously that easy comes with a big headache. But in essence, that's the road that we're going to. So that is all from my side. I'm going to hand you over to Jake now.
Thank you, Nils. By my watch, I've got negative 5 minutes, so I am going to blitz through this at a blistering pace. So I'm from the Central Analytics Department at British Airways, so I'm really I'm a data scientist, so I'm more of a consumer of tools built in AWS rather than a builder of those tools. And, Central Analytics is essentially where a lot of the kind of traditional operational research analytics functions in British Airways sits. So in addition to things like the engineering data sets that Nils is talking about, we deal with all the sort of the customer network design, as in the flight network, picking where its routes to go, how we balance our proposition. It's very long established, but it's also, as any large organisation, quite classic, and we have a lot of legacy that we have to deal with. And we are really excited to be working, in particular, with Nils' department in this area of integrating these sort of on-prem classical IT systems with cloud-based tools, such as the AI2 platform that Nils is putting together. Great example here is where we have the flight data recording that's coming in from Nils' platform, but then we have all of that tech log data, this classical, essentially it's the opposite side of that chain. It's the flight data recording saying, we think there's an action that needs to be taken, and then we have all of this recording that says, okay, someone actually went out, they took a look at something, and they did something or they didn't. And so one of the challenges we're dealing with at the moment is how you essentially tie those processes back together. I'm not going to go into any details because essentially I don't have any time. The last thing we're really interested in is trying to get something a bit more real time out into the operation. We have a huge amount of equipment out on the airfield. Apart from the planes, we have all of these vehicles, tugs, tractors, baggage conveyors, baggage caravans, and we are rolling out sort of telematics sort of systems to a lot of these, essentially to this entire fleet. We're also rolling out sort of automated driving, all of those kinds of things. And obviously, if you're going to do that, if you're going to put something that drives itself out on the tarmac at Heathrow, if you're going to put something that you can track in real time, that's very useful, but you have to actually be able to action that information. You need to be able to take that data in, ingest it, and present it to a staff of tens of thousands of people, all of whom are part of a massive moving machine that's going on at the same time. Clearly, there's a lot of work to be done. I think cloud solutions are absolutely critical to doing that properly. There's so much more I could talk about this, but I don't want to push us over any more time. If you're at all interested, do come and grab us in the breaks. I'd love to talk to you about this stuff. I'm sure Nils and Andy would love to talk to you about engineering data. And thank you.
Are there any questions from the audience? We've got time for one or so. One just here at the front.
Hi, I was just wondering if you had any problems interfacing Lambda with a relational database, and if so, how you got over those.
That's one for you, Nils.
So in terms of... yes, but there's not really... so in essence, what we have is everything runs in a VPC, and I guess there's a bit of an argument whether you want to run Lambdas in a VPC. Sort of our cold starts are usually between, let's say, a second and 3-ish. So in particular, what we see, because of the scalability of Lambdas, if you just hit it, you get timeouts, yes. And something that we're starting to trial now for about 2 or 3 months now is Aurora Serverless, which gets even worse at that point because, no offense, if you have something that sits at, I think, 2 capacity units sort of really, twiddling its thumb and sort of like, oh yeah, having a chill day, and like, suddenly it has like 50 requests from Lambda, it just goes like, what the actual? And so that is a really, really a good point. So when you have a regular RDS or whatever you provision for the worst case. So in our case, we went for the Amazon recommendation ×2 and got that as a reserved instance. On the other side, with serverless, yeah. So if you provision significantly over the top, which is what we did, you'll probably be fine. If you provision the serverless one, there's a bit of things where we're sort of also seeing timeouts, and especially if you hit it really hard, it just goes like...
Thank you. The the Aurora serverless does have a data API which does handle connection pooling, but then you do have the cold start problems at the beginning of when you hit it from cold. On the serverless stuff, you did mention in the talk, if everyone's worried about cold starts with VPC, look at V2N. It's a new technology we implemented. Cold start times are right down on VPC connected Lambdas, almost the same as non-VPC connected. We're rolling out across the fleet now. So, cool. Thank you very much, guys.